Alright, this video, I'm going to try to do this quickly because most of the stuff we'll know. It's going to recap valence electrons, and it's going to introduce Lewis dot structures, electron dot diagrams. Alright, so just to recap what the each group is called. Alright, each group, or excuse me, what each column is called. It's called a group or a family. Alright, and they're color coded here for us. Alright, we're going to ignore these transition elements. Alright, remember each period, that's the horizontal row, represents how many energy levels. All right, so that is located here. How many energy levels? So each period equals energy levels. All right, period energy level. Remember, period is the horizontal row. Sometimes I say this may not help anybody, but I'm like, when you write a sentence, you write sentences horizontally, right? They end in a period. So you can think like, a period is just like how I would write a sentence across. So if you can't remember which one's your group and which one is your the period, like as the group, or is it the period? Periods you write, if you write a sentence, you write it out like this, and then you put a period at the end. All right, that might help you. I don't know. Other things I've said, like, because these are called families, you stand up for your family. They're up. I don't know. They're just stupid things to hopefully help you remember. But and not only you have to know what the period is, but you have to know that equates to the energy level. So all the elements in period 1, hydrogen and helium are the only ones. They only have 1 energy level. All these will have 2 energy levels. All these will have 3. All these will have 4, 5, etc. And then each element in a group has the same number of electrons in their outer energy level. All right? And in the other notes, I talked about how they have common characteristics, just like a family. All right, so like these all have 1, these all have 2. I'm talking valence electrons, outer level electrons. When we go 1, 2, we skip this dip. 3, 4, 5, 6, 7, 8, except stupid helium, which only has 2. All right, so these numbers represent the valence electrons. Just recapping this. All right, we just did this like a day ago, so this should not be that much of a recap for you guys. All right, so the valence electrons, how many it has in the outermost level. Like I said, understanding this is going to be crucial for bonding. It's not hard. You just got to be able to count. All right, and you got to be able to know that you skipped that dip. All right, remember what? And just to recap, the reason why helium is in that group is in group 18, but it doesn't have 8. Because remember, every level is going to be filled with a Flotter shell with 8, all right, with exception to helium, which is just filled with 2. All right, because that first energy level, remember, that gets filled with 2, a max of 2. Every level past that is filled with 8. All right, so that's that octet rule. That's the exception to the rule, I guess you could say. Remember, in valence electrons, just once again, this is all recap. Valence electrons are electrons and the highest occupied energy level of the atom. So in the outer level, the highest occupied energy level are the only. Then, like I said, this is crucial because they're the only ones that get involved in bond formation. All right. So when we talk about chemical bonds, that's why these are important. Bohr atomic model structures. Now this is a very simplified version of a model that's changed slightly since then, but this is it Nicholas Bohr? I don't know. I forgot the guy's first name. He came up with this version of an atom, like where they went in orbits, and now we know they're more like in cloud structures. But we use this model because it really does help simplify things. All right, so this is usually how we construct atoms, even though it may not be 100% accurate. The model helps us represent it. All right, so once again, in that first energy level, contains only 2 electrons. All right. Now, if you weren't here the other day, the second and third can contain 8 electrons. We're not going to get. Don't worry about this. That is true, but you have to start getting into orbitals. I don't want to do that. All right. So we're not going to worry about that. Second and third can contain 8 electrons, a maximum of 8, we'll say. All right. So when constructing an atom, that's what we're talking about. All right. So Lewis dot structures are really simple. If you know how to find electron dot diagrams, instead of having to draw an entire atom like this to see, like we did yesterday with the when we did the electron, depending when you listen to this, the electron lab, the electron level lab, the electrons, we had to kind of go to figure out how many it had in the outermost shell. Dot structures are a lot easier to figure this out. So for example, and I'm going to do this as quickly as I can, like I said. So if I said draw a dot structure All right, because all that does is show outer level electrons for hydrogen, for lithium, for sodium. Jeez, I was blanking on what that was. All right, all you do to draw a dot structure, you only draw the valence shell. Well, if we know that these all have 1 in their outer shell, they all have the exact same dot structure. You do H, Li, all you do is you draw the symbol, and then you draw a dot to represent outer level electrons. Well, since these only have 1, Na has 1. All right, it's pretty simple. All right, now if I went to, let's say, carbon, carbon is located here. All right, if I wanted to draw a dot structure for carbon, it'd be 1, 2, skip the dip, 3, 4. So those all have, it's in group 14, it has 4. All right, so the way you do this is we're going to draw a dot structure. Now some people do it. Basically, you want to put a dot on each side. Some people draw where you have like an X, like a cross, and you put 1 on each side before you go and fill. I don't know. Just put 1 on each side before you start going around to the next. So you want. So if we drew a dot structure of carbon, that's what it would look like. All right, you'd have the chemical symbol, which is C, and then you draw 4 dots around it. Silicon would be the same thing because it's right below it. It's in the same group. So elements in the same group are going to have the exact same dot structure. All right. So like I'll give you dot structures on the test, and I'm going to say, hey, what group is this in? You're going to have to be able to tell me based on its dot structure. All right. So it's not going to be hard. If it's got 4, it's in group 14. If it's got 5, it's in group 15. All right. Because all you got to do is be able to, because these are numbered 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. All right, and then so like chlorine, let's say, would be here. Chlorine is in group 17, so its dot structure is going to be 4, 5, 6, 7. So I'm going to put a dot around each side, and then you pair the electron as you go. So I drew the chemical symbol. It's got 7, so now I'm going to go back through and I'm going to pair it up. I'm going to draw them in pairs. So the chlorine would look like that when I make the dot structure. So I put a dot on each side, and then I go back up and I pair it up. All right, so then I have that 1 extra remaining. And this is going to be a really simple way when we talk about bonding on how to do that. All right, so all you're doing when you do a dot structure, you write the chemical symbol, make sure it's a capital letter and a lowercase. Don't put 2 capital letters. I will mark that wrong if you do that. Capital letter and a lowercase letter if it has 2. And then all you do is you just put the number of dots around it that represent the electrons in the outer shell. All right, and put 1 dot on each side before you double them up. All right, so that's really all that is. All right, you write the symbol, and you put a dot around each edge. All right. So yeah, this one has it going counterclockwise. I don't really care which way you go. To me, it's not that important. All right, so they have it starting at the right going here. I started here and went this way. That's not that big a deal to me, as long as we fill around it. All right, and then like I said, you really can't miss these as long as you are going through and just double checking your work. All right, so like I said on the test, most of these I'm going to say like you'll have something like this. Some of them will just be unknown elements, and I'll say what, like I'll give you like X, and I'll say what group is X in? Well, it's got 2 in the outer shell, so I got to know that is in group 2, because these would all have the same dot diagram. If I gave you one that looked like this, that would be Y. It has 1. These all have 1 in their outer shell, so it would be in group 1. All right. So these are the kind of problems that I'm going to give you on the test. You have to be able to tell where it would go on the periodic table based on how many it has in the outer shell. All right. Hopefully that's not too tough. I really don't think it is. So, all right.